video camera on. This is the domain. So I'm going to go from -3, including, and it doesn't really matter when I put my walls up, to 0. So x equal -3. X equals 0. And x greater than 0. If I look at the domain, it starts and includes -3. Stops at 0. Picks up x equals 0. And x greater than 0. So in this instance, what's shaded? -3 to 0, right? The -3 to infinity. So that says, that's where interval notation comes in really handy. It starts at -3 and includes, because it's a solid dot, comma, infinity, and that's your domain. There's nothing to the left of -3. That's why I do the number line. That way I kind of know where things are going to hit. Because it's not always minus infinity, infinity. Now, again, I'm going to ignore the x-intercepts because they're too much of a pain to get if I'm going to do them algebraically. The y-intercept is easy because that's where x equals 0. And if I look, who encompasses x equals 0? Y equal -3. So it's 0, -3. So here we go. We've got essentially 3 graphs. Between -3 and 0, I have 2x plus 5. So I'm going to look at this guy. It's where -3 is less than or equal to x, strictly less than 0. X, 2x plus 5. -3 is solid. Now here's the good news. The good news is that it's a straight line. How many points do I need to graph? 2. So I can just graph -3 and 0. 0 it does not include, so it's open. So if x equals -3, I'd have 2 times -3 plus 5, which is -6 plus 5 is -1. And if x equals 0, 2 times 0 plus 5 is 5. Now, here's the thing. On this next test, what problem will you probably leave to last? This one. You'll answer what you can of this one. Answering what the domain is easy. Answering what the x-intercept is, or y-intercept is easy. Everything else is going to be a pain in the rear because it's going to take time, because the graph, this is 3 graphs, 1 piece of graph paper. So it's like you're doing 3 different graphs. So it takes time. So -3, -1, solid dot. 0, +5, 1, 2, 3, 4, 5, open dot. And then draw the line. We've got an x-intercept here. And then we pick up, if x equals 0, y equals -3. It's just a coordinate point. 1, 2, 3. Just a dot. And the third one is x greater than 0. I have negative 5 times x. So I pick 0. This is open. Get that over there. And I'll pick 1 because I need a number greater than 0. 1 is fine. 0, 0. 1, negative 5. And again, it is a straight line. As long as you're dealing with straight lines, you're okay. So 0, 0, open dot. And 1, negative 5. That's an icky looking graph. What's the range on this graph? Looks like it starts what? Negative infinity and then stops where? At 5, right? So it's open at 5. So then that says y is greater than negative infinity, but less than 5 since it's an open dot. So this would be negative infinity, positive 5, open, open. And it looks like it has an x-intercept. What you would guesstimate the x-intercept to be? Negative 2.5. And that's just a guesstimate. But I know what graph it's on. It's on that first graph. So if I wanted to actually find the actual value, I would just set the first graph equal to 0. So y equal to 0 on the first one. If I needed an exact value. I think this is probably one of the least fun things that we do.